So we've taken our equation and we've substituted in our two-scale substitution. And in this case, we're using u as a function of the slow variable and v as a function of the fast variable. So u is a function of tau, which is epsilon t, and v is a function of t. So we found out in terms of those variables what our differential equation looks like. And our next step is to substitute in a perturbation solution. So we're going to write the product as a sum of terms. First one is zero order in epsilon, followed by one first order in epsilon. And then there should be a load of other terms, but we're not going to bother with those. So we're going to substitute these into equations, and we're only going to keep terms up to order epsilon. So we're going to have u naught dv naught dt squared plus epsilon u1 d2 v1 dt squared. Then the next term comes its own epsilon, so we're only going to keep the zero order term for this. So 2 epsilon du naught d tau dv dt. Next term, this one here, this is already second order in epsilon, so I don't worry about that. Next term, I'm just going to keep the zero order term because it's already got an epsilon. So plus epsilon u naught dv naught dt. This term, order epsilon squared, I don't put it in. And then for the final term, u naught v naught plus epsilon u1 v1, and all this equals 0. So next I need to look at the initial conditions. So at t equals tau equals 0. So I've got u naught v naught plus epsilon u1 v1 equals 1. And then for next term, we're going to have u naught dv naught dt plus epsilon u1 dv1 dt. This term, and then for this term I only keep the zero order. So plus epsilon du0 d tau times v0, and all this equals 0. So my next step is to pull out the terms of order epsilon 0 and the terms of order epsilon 1. So for epsilon 0, that's u naught d2 v naught dt squared plus u naught v naught equals 0 with initial conditions u naught v naught equals 1, u naught dv naught dt equals 0. For epsilon 1, we've got u1 d2 v1 dt squared. These two terms I'm going to put on the right hand side, so I'm going to hold off on these, plus u1 v1, and then I'm going to have some terms over the other side, so minus 2 du naught d tau, that should be a v naught there, dv naught dt minus u naught dv naught dt equals 0, with initial conditions u1 v1 equals 0 and u1 dv1 dt plus du naught d tau times v naught equals 0.